Welcome to a video that we're going to introduce to you the quadratic formula and show you how to apply it to solve quadratic equations. So we've already had some experience solving quadratic equations by taking the square root of both sides, and that's when you have only a quadratic term and a constant term. But then when we have a quadratic trinomial like this, we've tried to factor this and set each factor equal to 0. So that's called solving quadratic equations by factoring. But here, I cannot take the square root of both sides because I have a linear x term. I also realize that this particular trinomial will not factor because what two numbers multiply together to equal -2, but also add together to equal -3? Well, you have to have a negative and a positive here. And so this one will not factor. So what we're going to do is we're going to use the quadratic formula. And that's the purpose of this video, is to show you how that works. For the quadratic formula, you want to turn the equation, if not given in standard form, write it in standard form. And then identify your a, which is your quadratic coefficient, your b, which is the linear coefficient, and your c, which is your constant term. And once you do that, we know that we can look up the quadratic formula, but hopefully you're starting to memorize it, that it's -b plus or minus the square root of b squared minus 4ac all over 2a. And so what we do next is we substitute in the values. So -b means the opposite of b. So that's 3, right? The opposite of -3 is 3. Plus or minus the square root of b squared. So that's going to be -3, which should be in parentheses, squared, minus 4 times a, which is 1, times c, which is -2, all over 2 times 1. So now we want to simplify inside the radical. And we get 9 here, and we get +8 there. So 9 minus -8, or 9 plus 8 is 17, all over 2. And so those are the two solutions to this quadratic equation. There are two solutions. There will never be more than two for a quadratic equation. This one has two solutions. One equation is 3 plus the square root of 17 divided by 2. The other one is 3 minus the square root of 17, all divided by 2. So those are your two solutions to the original quadratic equation. Those are the values of x that would make this equation true. All right, let's go on to the next example. In this example, we have a leading coefficient a, which is something other than 1, b is 5, and c is 1. And so we're going to substitute into the quadratic equation, the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4 times 2 times 1, all over 2 times 2 this time, because it's 2a. So now we're going to simplify inside the radical. We'll do some mental math here. That's 25 minus 8. 25 minus 8 is 17, which is not a perfect square. So I have my two solutions. One solution, and by the way, we can also separate this into two separate fractions, so I'll write it that way. So one solution is -5/4 plus the square root of 17/4. The other solution is -5/4 minus the square root of 17/4. So that is how we use the quadratic formula to solve quadratic equations once the equation is written in standard form.